So guys, I guess I fixed the issue. It was not, I guess nothing like my browser, um, like uh, the zoom aspect of my browser was a little messed up, but yeah, it looks smooth now, um, as compared to the previous one, how it was looking. So yeah, let's jump on to the um, Three.js documentation and let's do this. Okay. Even though this is becoming less and less of a problem, some devices or browser may still support WebGL. The following method allows you to, let me zoom it a bit. Okay, yeah, I guess this is much better. And okay, sorry. Okay, okay. Browser R. The following method allows you to check if it is supported. We've done this. So let's draw lines. Let's say you want to draw a line or a circle, not a wireframe mesh. First, we need to set up a renderer and scene and camera. See the creating a scene page. Yeah, we did that. Here is the code. So we do this WebGL renderer, set size window inner width, inner height, and then append renderer to the DOM element. And the perspective camera is 45 by inner width. Okay, so half of it, and 1 and 500. And camera position set 0, 0. Look at 0, 0. Next, next thing we will do is to define a material for lines. We have to use line basic material or line dashed material. Okay, so I guess this is important. If we go back, we have this guy, and okay, so let's create one more. Draw line.js, paste this guy here, and we'll be needing this. So we created a new instance of this perspective camera, then window inner height inner. Okay, then what we do is in the index, go and create, then draw line.js. Okay, so we do this, and the next thing that we gotta do is we have to set the scene. We already set a camera. Actually, we need to do all of this, and I did not do it. So let's do this. Render, renderer set size, camera, 3 dot perspective. Okay. Then we create a scene, and in that scene, I guess we need to add all of this. Next thing we'll do is to define a material. Okay. Or dash material, line material or dash material. Create a basic. Okay. Um, can we see what change? Okay, there is no change and it's too bright. Okay, let's go here. After material, we will Need a geometry with some vertices. Okay, so const points, we have all of this. Let's go back to the VS Code and let's paste this. And let's see point dot push new 3 vector 3. Okay, I guess once we understand what's going on, but yeah, like, okay. Note that lines are drawn between each consecutive pair of vertices, but not between the first and last. Okay, now that we have points for two lines and material, we can put them together to form a line. Still nothing. Geometry. So here we are putting together geometry and material to form a line. Okay, we'll add this to a scene called renderer render. But okay, now let's go and find out. Oh, okay, we have drawn this. If you guys are able to see this, we have drawn this. So -10, you should now be seeing an arrow pointing upwards made for from two blue lines. Yeah, I did see. Creating next. Creating text, sorry. There are often times when you might need to use text in your Three.js application. Here are a couple of ways to do that you can do so. Using HTML is a generally the easiest and fastest manner to add text. This is the method for using descriptive. Okay, loading 3D model. 3D models are available in hundreds of file formats, each with different purpose, assorted features, and varying complexity. Although Three.js provides many loaders, choosing the right format and workflow will save time and frustration later on. Some formats are difficult to work with, inefficient for lifetime experience, or simply not fully supported at this time. This guide provides a workflow recommended for most users and suggestion for what to try if things don't go as expected. If you're new to running a local server, begin with installation first. Many common errors viewing 3D models can be avoided by hosting files correctly. Where possible, we recommend using GITF GL transmission format. Both GLP and GLTF versions of the format are well supported because GITF is focused on runtime asset delivery. It is compact to transmit and fast to load. Features include a mesh material, texture, skin, skeleton, and morph, target animation, light, and camera. Public domain GITF files are available on site like Sketchfab or various tools including IGFT, Render Foundation. If you prefer tool do not support IGFT, consider requesting author. Okay, How do one learn such things on their own? How do people learn it? Okay, is there a better way of understanding what's going on? This looks cool. Ah, where were you hiding all this time? Okay, let's try to understand what the fundamental is. This is the first article in a series of articles about Three.js. This is nice. Three.js is a 3D library that tries to make it as easy as possible to get 3D content on a web page. Three.js often confused with WebGL since more often than not, but not always, Three.js uses WebGL to draw 3D. WebGL is a very low-level system that only draws points, lines, and triangles. To do anything useful with WebGL generally requires quite a bit of code, and that is where Three.js comes in. It handles stuff like scene, light, shadows, materials, textures, 3D math, all things that you'd have to write yourself if you were to use WebGL directly. These tutorials assume you already know JavaScript, and for the most part they will use ES6 style. See here for a terse light of thing you've expected to already know. Most browsers that support Three.js are auto-updated, so most users should be able to run this code. If you'd like to make this code run on really old browser, like look into transpiler like Babel. Of course, user running a really old browser have machine that can't run Three.js. When learning most programming languages, the first thing people do is make the computer print hello world for hello world. For 3D, one of the most common thing to do is to make a 3D cube. So let's start with hello cube. Before we get started, let's try to give you an idea of the structure of Three.js app. A Three.js app requires you to create a bunch of objects and connect them together. Here's a diagram that represents a small Three.js app. There is a renderer. Okay. and there is a scene which has mesh, object 3D, mesh, group, light, camera. Okay. Things to notice about the diagram above. There is a renderer. This is arguably the main object of Three.js. You pass a scene and a camera to a renderer, and it renders a draw the portion of the 3D scene that is inside the fructum of the camera as a 2D image to a canvas. Okay, there is a scene graph which is like a tree structure consisting of various objects like a scene object, multiple mesh objects, light objects, group object 3D, and camera objects. A scene object defines the root of the scene graph and contains properties like the graph background color and fog. Scene graph. These object defines a hierarchical parent and child tree-like structure and represents where objects appear and how they are oriented. Children are positioned and oriented relative to their parent. For example, the wheel on a car might be children of the car so that moving and orienting the car object automatically moves the wheel. You can read more about this in the article of scene graphs. Note in the diagram, camera is half in half out of the scene graph. Okay, yeah. This is to represent that in Three.js, unlike the other objects, a camera does not have to be in the scene graph to function. Just like other objects, a camera as a child of some other object will move and orient relative to its parent object. There is an example of putting multiple camera objects in a scene graph at the end of this article, the end of the article of scene graph. Mesh object. Mesh objects represent drawing a specific geometry with a specific material. Both material object and geometry object can be used by multiple mesh objects. For example, to draw two blue cubes in different location, we could need two mesh objects. Okay, let's read it again. I didn't understand it. Woo. Okay. Sorry, guys. It's sleep time, but I'll do this like for next 10-15 minutes and then I'll say bye. That's overlapping. Okay. Mesh objects represent drawing a specific geometry with a specific material. Okay. And I have observed I say okay a lot, so I need to stop saying that. But I reassure myself that I understood this point and say okay, which is not okay. I should not say that often. Mesh object represents drawing a specific geometry with a specific material. Both material objects and geometry objects can be used by multiple mesh object. Mhm. Both material object and geometry object can be used by multiple material and geometry object can be used by multiple mesh object. Okay, there we go. Again, for example, to draw two blue cubes in different location, we could need two mesh objects to represent the position and orientation of each cube. We could only need one geometry to hold the vertex data for a cube, and we would only need one material to specify the color cube. Both mesh object could reference the same geometry object and the same material object. Geometry object represents the vertex data of some piece of geometry like a sphere, cube, plane, dog, cat, human, tree, building, etc. Three.js provides many kind of built-in geometry primitives. Oh, built-in geometry primitives. You can also create custom geometry as well as load geometry from files. Material objects represent the surface property used to draw geometry, including things like the color to use and how shiny it is. A material also references one or more texture objects which can be used, for example, to wrap an image onto the surface of geometry. Texture object generally represents images either loaded from image files generated from a canvas or rendered from another scene. Light object represents different kind of lights. Given all of that, we are going to make the smallest Hello Cube setup that looks like WebGL renderer, perspective camera, scene, mesh, box geometry, mesh basic material. It is important you put type module in the script tag. This enables us to use the import keyword to load Three.js. As of R147, this is the only way to load Three.js properly. Modules have the advantage that they can easily import other modules they need. That saves us having to manually load extra scripts that are dependent on. Next, we need is a canvas tag to um, okay, we will ask Three.js to draw into canvas, so we need to look it up. After we look up the canvas, we create a WebGL renderer. The renderer is the thing responsible for actually taking all the data you provide and rendering it onto the canvas. This is important. Okay. A note, there are some esoteric details here. If you don't pass a canvas into Three.js, it will create one for you, but then you have to add it to your document. Mhm. Where to add it may change depending on your use case, and you will have to change your code. So I find that passing a canvas to Three.js feels little more flexible. I can put the canvas anywhere, the code anywhere, and the code will find it. Whereas if I had the code to insert the canvas into the document, I'd likely have to change that code in my use case changed. Next up, we add a need a camera. We'll create a perspective camera. FOV aspect near far camera. So so given this four defaults, four parameters, camera perspective camera is made. Okay. FOV is short for field of view. What is my field of view? Okay. In this case, 75-degree in the vertical dimension. Note the most angle in Three.js are in radians, but for some reason the perspective camera takes degree. Aspect in is the display aspect of the canvas. We'll go over the details in another article, but by default, a canvas is 300 into 150 pixels, which makes up the aspect ratio 350 by 150 or 2. Okay, the canvas default. Mhm. Near and far represents. So what did we use in while we were creating the camera? 45 and 350 by 150 the canvas height. So canvas default is so 3 dot perspective camera. Okay, I guess I need to push this or else, yeah. Perspective camera, FOV, field of view, then aspect, then near and far, right? That's what makes up, yeah, near and far. Okay, near and far represents the space in front of the camera that will be rendered. Anything before that range or after that range will be clipped. Anything before or after that range will be clipped. Those four settings defines a frustum. 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 I don't know how to pronounce it. Frustum. A frustum is the name of a 3D shape that is like a pyramid. That is like a pyramid. Oh, frustum. This guy. That is like a pyramid with a tip or with is like a pyramid with the tip sliced off. In other words, think of the word frustum as another 3D shape like sphere, cube. Okay, near, far, and anything beyond that will be deleted. And this is the field of view, field of view. So am I able to see this much or the whole box? The height of near and far plane are determined by the field of view. The width of both planes is determined the field of view and the aspect ratio. Mhm. Anything inside the defined frustum will be drawn, anything outside will not. The camera default to looking down the z-axis with plus y up. We'll put our cube at the origin, so we need to move the camera back a little from the origin in order to see things. So here is the camera. Initially it's like this, and our cube is this. Minus x plus x minus c plus c. In the diagram above, we see our camera is at z2. It's looking down the minus z axis. So here our camera is at which axis? If I do this and go here and uncomment this and comment this, oh, it become larger, like came more to the front. So according to this, but in the diagram above, we see that our camera is at Z2. It's looking down the minus Z axis. So is it like this, like down? Our frustum starts at 0.1 units from the front of the camera and goes to 5 units in front in front of the camera, because in this diagram we are looking down. The field of view is affected by the aspect. Our canvas is twice as wide as its tall, so across the canvas the field of view will be much wider. Next we make a scene. A scene in Three.js is the root of a form of scene graph. Anything you want Three.js to draw needs to be added to the scene. We'll cover more detail how scenes work in future article. Next up, we create a box geometry, box width, height, depth. which contains data for works. Almost anything we want to display in Three.js needs geometry, which defines the vertices that makes up our 3D object. We then create a basic material, set its color. Okay, colors can be specified using standard CSS style, 6 digit. We then create a mesh. A mesh in three represents the combination of three things: a geometry, a material. Okay, sorry, a geometry. We then create a mesh. Mesh is a combination of geometry, material, how to draw the object, shiny or flat, what color, texture, the position, orientation, and scale of the object in the scene related to its parents in the code. Okay, but we did not animate this. That's why it's kind of hard to tell that it is a cube since we are viewing it directly down the z axis minus z axis and the cube itself. So z is like this. So is it like this? Oh, I guess yes. It's the top view. It's the top view, like I'm viewing it in this way. Here's here's y and here's x, and in between I guess is the z axis, and that's why we are able to see the front of it, right? Is that true? I So here is x, here is y, minus and plus. Okay, the, I perceive it. It's something like that, but okay, let's see. It's kind of hard to tell that it is a 3D cube since we are viewing it directly down minus c, so like straight, and the cube itself is an axis aligned, so we are only seeing a single face. Let's animate it spinning and hopefully that will make it clearer. It's being drawn in 3D. To animate it, we'll render request animation frame. Request animation frame is a request to the browser that you want to animate something. You pass it function to be called. In our case, that function is render. The browser will call your function, and if you update anything related to display of the page, the browser will re-render the page. In our case, we will call 3render renderer.render function, which will draw our scene. Request animation frame passes the time since the page load to our function. That time is passed in milliseconds. I find it's much easier to work with seconds, so here we are converting that to seconds. We then set x and y rotation to the current time. These rotation are in radians. There are 2 pi radian in a circle, so our cube should turn around once each axis is about 6.28 seconds. We then render the scene and request another animation frame to continue our loop. It is it's a light better, but it's still hard to see the 3D. Um, what would help is to add some lighting. So let's add some lighting. There are many kind of light in Three.js which will go over in future article. For now, let's create a directional light. Const color, intensity, directional color intensity, position. Directional light have a position and a target. Both default to 0, 0, 0. In our case, We are setting the light position -1, 2, 4. So it's slightly on the left hand side. Okay. And behind our camera, the target is still 000, so it will shine towards the origin. We also need to change the material. The basic material is not affected by light. Let's change the mesh form material which is affected by light. Mesh form material. Okay, let's put that. Let's see how our cube looks like. Whoops. Where is our cube? What? Yeah, this is looking much better. Okay, let's see. It should now be pretty clearly 3D just for the fun. So let's add two more cubes. We'll see the same geometry of each cube, but make a different material so each cube can be a different color. First, we'll make a function that creates a new material with specified color. Then it creates a mesh using specified geometry and make instance color X. Okay, cube. Whoa, there are multiple cubes now. Okay, got it. If you compare it to the top-down diagram above, you can see it matches our expectation. With cube x minus 2 plus 2, they are partially outside our frustum. They are also somewhat exaggeratedly wrapped, warped, since the field of view across the canvas is so extreme. As you can see, we have three mesh objects, each referring the box geometry. Each mesh references a unique mesh form material so that each cube have a different color. So this is a nice way of learning things. I'll bookmark this. I'll bookmark this. Got it. But yeah, like we'll keep reading it and let's see if um, we have anything. Yeah, three Three.js. So this guy is using Sean Bradley. Who is this guy? He's doing Three.js on top of Webpack, Mesh, Wong. He's going over every little detail slide. Okay, but yeah, that's what we are also doing, right? Well, yeah, following this manual, and hopefully he also did the same thing. And by the end of it, okay, yeah, we loaded this guy, and hopefully we'll be able to make some good progress. And my goal is to make this kind of thing. Three.js. I don't know when I'll be able to make this. Yeah, this guy, right? It's loading. Give it a second. This kind of stuff I want to make. This is so fancy, cool looking. Like I want to know what it takes to make this kind of thing. Okay, no worries. We will do that in some other video, but till then. Okay guys, I've gotta go. Let's see, catch you in the next